Semula. Okay.
Eh,
Satu, dua, tiga.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Saiful Anwar bin Aminuddin from class EMD 5M1B for class MEC 523, and I will presenting for the assignment 10% for this subject. So for my part is component explanation. For the first part, we use Arduino R3 and function as a microcontroller based board based on the and used to control and process input or output in electronic circuit. So for the key features is 14 digital input and output pin, 6 analog input pin and USB interface for programming and power, and act as the main controller to manage input such as my ultrasonic sensor and photoresistor, and output LEDs and LED screen. So for the second component is LED light, which is red and green. Uh, it function for emit light when current flow through them, and also for the purpose in this circuit is to indicate different distance range and detected by the ultrasonic sensor, such as red light blink 10 times at 100 centimeter, and red light stays on at 200 centimeter, and so on. And for the third component is 16 times 2 LCD screen. Uh, it function as a display alphanumeric character in 16 column and 2 rows. And purpose of the component in the circuit is to show distance measure by the ultrasonic sensor and other message. And the key component is often used in 5C module for easier wiring with Arduino. For the fourth component is photoresistor or LDR, light dependent resistor. So the function is resistor whose resistance decrease with the increasing light intensity, and the purpose in the circuit is act as an input to enable or disable the operation based on light condition. For the fifth component is resistor itself to limit current to protect LED and other component. So the purpose in this circuit is to prevent LED from burning out and work in conjunction with the photoresistor for better sensitivity. And for the last part is ultrasonic sensor, as we use in the circuit is HCSRO4, and the function is measure to distance by emitting ultrasonic wave and calculating the time it takes for the echo to run. And the purpose in the circuit to detect distance from 100 centimeter to 100 centimeter and 300 centimeter, and trigger corresponding LED behavior. So that's from me. Thank you.
Assalamualaikum and a very good evening. My name is Muhammad Amiruddin Muhammad Adwan. So today I'm going to explain a bit on wiring that plays a necessary part for the circuit to working very well. So let's start off with the LCD first. As we all know, the LCD connected to Arduino to receive any information, and the RS pin will connect to the digital pin number 8. Meanwhile, the enable pin will connect to the digital pin number 9. And the up next is the DD4, DD7, DD5, DD6, and DD7 will each connect with the D number 4, digital pin number 4, digital pin number 5, 6, and 7 for each pin. And the Arduino will connect with 5 voltage of supply for it to work. And the next we go for potentiometer. The potentiometer will connect to 5 volt of power supply, which the same volt as Arduino use, and it connects to ground and the VO pin to the Arduino. And next we have ultrasonic sensor. It has 4 pin. It has a VCC, trigger pin, echo pin, and ground pin. For VCC pin, we connect it to 5 voltage, and for trigger pin, we connect it to D10, digital pin number 10, to read to send signal. And for echo, we connect it to D11, digital pin 11. The main function for this is to receive reflect signal and to calculate distance of the reflected signal. And for ground, as we all know, it will connect to the Arduino ground. And for the LED, we use two LED, the red LED and green LED. For red LED, we connect to the to the D12, digital pin number 12, and for the green LED, we connect to the digital pin number 13. Both LED has a current resisting limiter to limit the current go to the LED, or otherwise it will malfunction or it will blow off. This LED is connected in series, and the negative leg of the LED is connected to ground. The one connected LED between LED is the positive leg. For the photoresistor, this photoresistor is also a necessary component because it is a part of voltage divider. The photoresistor has two legs. The first leg will connect to the 5 volt for currents for the power supply, and the other leg will connect to the A0 and resistor. The resistor has two legs. That one is connect to the photoresistor, and the other leg will connect to the ground. And to conclude all power supply, this each of these component connected their own power supply to the Arduino. As we can see on the Arduino, it connected to the laptop or PC via USB connection. We receive the power supply from the laptop itself for the power. That's all for me. Thank you.
Alright, so right now I want to explain to you about the coding that we use for this project. As you can see, first of all, we include the libraries that use liquid crystal. But first of all, I cannot open my camera because I was recording this meet. So I just explain to all of you. So for the libraries, we use the liquid crystal, and then we define the trigger pin of the ultrasonic to the pin number 10, like the Amirul said earlier, and then the echo pin into the 11. And for the distance that we want to calculate, we use the define of TRV time, and the distance we use the integer. And then we go for the void setup. We define that the trigger pin is as the output for this circuit, and then the echo pin as the input. This act as the receiver from the ultrasonic sensor to the Arduino. And then both of the LED we use for the output. Then for the loop setup, we use the serial print of the LDR value to determine if the photoresistor is working well or not. And then if the photoresistor read the value above from the 500, it will on all the circuit operation. So as you can see, that when the distance that ultrasonics detect, if the range of the 90 until the 110 cm, it will light up the red pin, the red LED. And then for 4.5 second it will turn off for the 10 times. And then for the distance of range 190 until the 110 cm, it will light up the red LED. And for the distance above 290 and a range of 310 cm, it will light up the green LED. And that's all for me.
Okay, Assalamualaikum warahmatullahi. My name is Muhammad Naufal, and for my session, I will present the practical demo and a simple explanation about the system. For the first, I will state about the initial condition, which is after powering on, the system analyzes the LCD and set up the pin modes. And after that, it's begin to read from the LDR and ultrasonic sensor. After that, about light detection, which is the system continuously will monitoring the LDR value, and if the light level is greater than defined threshold, which is 300, it assumes the light is present and activates the distance measurement. And if light is not detected, it displays no light detected on the LCD and turn off the LEDs. About the distance measurement, the ultrasonic sensor is triggered to measure the distance to an object in front of it. And if the distance is read successfully, it converts the time taken for the echo to return into the distance measurement in centimeters. And display output, which is the LCD, will show the ultrasonic and the measure distance. And it will refresh only when the distance measurement change to provide clear and update information. For the LED indicator, which is based on the distance measure, the system will control the two LED, which is red and green. And first, if the distance is between 90 until 110 cm, the red LED will flash 10 times. Second, if the distance is between 190 until 210 cm, the red LED is on and the green LED is off. Third, if the distance is between 290 until 310 cm, the green LED is on and the red LED is off. And lastly, if the distance is outside this range, both LEDs are off. And the delay between readings, which is the system pause for half a second between reading to prevent flickering and exceeded data on the LCD. That's for explanation practical demo. And lastly, I will conclude our project, which is In this project, we built a simple system that uses a light sensor, LDR, and ultrasonic distance sensor. The system detects light levels and measure how far away an object is, using an Arduino to make everything work together. And we display important information on an LCD screen, show the amount of light and distance measured. The project also includes two LEDs, light that change based on distance, which is one flash, one stay on, or both turn off, providing clear visual feedback. This project helped us to learn about working with sensor, reading data, and use display. This shows how different electronic components can be combined to create an interactive device. The final system is virtualized and could be used in various ways, such as automated system or phone monitoring environment. Overall, this project demonstrates how simple technology can be used to create useful and responsive devices. That's all from us. Thank you.